Welcome to physics class. I'm excited that we're going to be going through this topic together. And the interesting thing about physics is that it affects literally every other field of study. We'll start out talking about motion and anything from your cars to how you move to how you throw a baseball. All of those are involved in the kinematics of motion. We'll move from there into force, pushing and pulling on things, energy and work. And then towards the end of the year, we'll be doing things in the fields of optics, sound, electricity. And so because we can see and hear all of the light and sound waves that are moving through the electricity that you're using even to watch this video right now, all of that is a part of the field of physics. So I'm glad that we're going to be working through this together, and I'm looking forward to a great year together. This video is just going to give you some very basic information about how the class is going to be set up. Most of the information is also going to be able to be found in printed form in the student letter that I've sent you. So you don't need to take notes or anything during this. I'm just going to be presenting it in just another format so that hopefully you'll understand how everything's going to be set up and what you can expect. The textbook that we are going to be using is Dr. J. Wiles' Exploring Creation with Physics, and you can figure out what you're going to be doing every day by looking at the daily lesson plans that I've sent. It's basically going to look like a checklist organized by day. Most of the time you're going to start out with a reading assignment in the textbook, and from there, many days, I will give you a link to a video very similar to this one where I will be explaining the topics and going through some sample problems, helping you understand some of the more difficult concepts. Then it will be time for a homework assignment. And your homework will come, again, almost always from the textbook. You're going to start usually by doing what are called on your own questions. And the on your own questions are located in the yellow boxes as you read throughout the chapter. So what you want to do is you want to read through those questions, actually get a piece of paper and write down your answer to the on your own questions. When you write it down, instead of just trying to solve it in your head, it actually makes you think through it and commit to some sort of an answer. So that is something that you should write down. Then once you have it written down, the answers to the on your own questions are at the very end of the chapter, right before the review questions and the practice problems that are back there. So you should go back, you should check the answer to your on your own question and make sure that you got it right. If you didn't get it right, you need to correct it. My view on homework is that this is your time to learn the material, to understand it. And so for homework, you're never going to be penalized for a wrong answer. You can get 100% on your homework, which is 20% of your grade, if you simply work every problem, show all your work, make your very best effort at doing it, then check your answers and make sure that you correct anything that you haven't gotten correct when you work the problem the first time. So the on your own questions are scattered throughout the chapter. Then at the end of the chapter, and let me find it here, you will find review questions and you will find practice problems, again, at the very end of the chapter. And in the back of the book, in Appendix B, there are some extra practice problems as well. Now, what I'm going to do is I will assign some of those every single day to go with the section that you just read. If you read the author's introduction, you will find that he tells you that those problems should not be worked until you get to the very end of the chapter. And my experience, what I have found, is that students are actually much better served if they get a lot more practice with the material at the same time that they're learning the material. So I prefer to have you work those problems as you go through the chapter itself. Then, again, when you finish those problems, the answers are in the solutions guide, and either you'll need to come to an agreement with your teaching parent as to how you're going to do this, whether they're going to check your answers and give you the paper back to correct it if you miss any, or whether they will give you access to the book and you'll get to check your own answers. So that's a discussion that you'll need to have with them. But the answers for all of those other questions are located in this guide. So homework is 20% of your grade. Then there are lab experiments that you will be doing. Most of them, again, are going to be found in the textbook, but there may be other times where I will send you a different experiment, or there may be something online that we will be doing instead. And I'm going to ask you to write that experiment up, and then you'll turn that in to me and I'll grade it. So you'll need to keep a lab notebook. And what I normally do is, my kids have always used a notebook similar to this one. And the reason I have them keep their experiments in a separate notebook is that way, if a college ever asks you, was your physics course actually lab-based, you can say, yes, it was, and then you will be able to show them your lab notebook and they can see exactly what you've written up. Before you do your first experiment, I will give you some very specific instructions as to what your lab write-up should look like, how it should be presented in your notebook, and then I will also give you specific instructions for each lab as to what I'm looking for in that specific lab write-up. If you ever have any questions, make sure you ask me about that, but you will be taking a picture of that and then sending it to me, and then I'll grade it. So 20% homework, 30% experiments, and then that leaves 50% for your tests. Now, on a test, your test is always going to be closed book. You can always use a calculator. You will most definitely need a scientific calculator for this class. If you've taken chemistry already, I'm sure you probably already have one. And also for physics, you are always allowed to use a note card. This is a 3" by 5" note card. If they don't come exactly that size in the country where you happen to be, that's not a problem. Just use something similar to this size. Any mathematical formula that you use in the chapter, you may write down on a note card and then use the note card on the test so that you don't have to memorize all of the formulas. You can always go back and look up a formula if you need it, and so that's why I believe that you don't necessarily need to memorize them all. Some of them you will have memorized just because you will use them all of the time, but this will help jog your memory if you forget what the formulas are. There shouldn't be anything else on the note card besides your formulas, but you may always use that on your test. And so then when you finish that, you'll take pictures of that and send that to me as well for grading. There will be, again, some specific instructions in the daily lesson plans for how to submit a test, for different ways that you can go about completing it. So you can look for that at the end of the first chapter of daily lesson plans. If, as you're going through studying physics, if you come across some questions, if you have trouble understanding things, please make sure you ask right away. I always try to answer questions within 24 hours so that you can keep moving forward. And if you start to get lost and you don't get the answers to those questions relatively quickly, your confusion is just going to mount and you're going to get more and more lost. So make sure that if there's something you don't understand, that you get that question answered right away. When you communicate with me, I've also given you in your student letter some specific ways that I would really appreciate when you send me an email, if you would put in the subject line what class you're taking, because I do teach classes other than physics. So physics module 2 question, or physics module 3 experiment 3.2. You know, as long as it's real specific in that line, in that subject line, what you're communicating to me about, that will greatly aid in my being able to get back to you quickly. Also, if you prefer to use something like WhatsApp, I'm fine with that as long as your parent agrees with that. So just make sure that you've checked with them and that the two of you are in agreement, and then let me know what that looks like. Also, if you wouldn't mind sending me just a small headshot of yourself, it helps me to keep my students straight in my head. I promise I won't post it anywhere online. It will only go in my records and maybe on the wall above my desk, just so that when you send communication to me, I can have a picture in my head of what you look like, and I can kind of keep all my students straight that way. If you don't feel comfortable doing that, it's not a requirement. It's just something that helps me make a more personal contact with my students. There are some assumptions that I have regarding information that you already know coming into this class, and the author does go through these things in the first reading assignment that I will give you in the book. If you've already taken a good chemistry course, you've probably already covered almost all of this, and so it shouldn't be an issue. I assume that you know the metric system. I assume that you know how to use the factor label method when you're making conversions. I assume that you know how to deal with units in equations such as meters and seconds and any other type of unit that you might be using. I assume that you know how to measure things and how to get the most amount of significant figures out of your measuring device. I assume that you understand the difference between accuracy and precision, and you know how to use significant figures. And I also am assuming that you know how to use scientific notation. If any of those things you're a little rusty on, in the first day of your lesson plans, it will be your job to make sure that you've boned up on all those things and you have gotten all those things fresh in your mind. You've dusted all the cobwebs out of your brain, maybe from over the summer. I will give you some specific resources that if you're unsure about any of those areas, that you'll be able to go back and review those areas and make sure that you're on top of things. You also need to know the 3 basic trig functions, sine, cosine, and tangent. We won't be using those until about chapter 3, so that you don't have to go back and review those immediately, but you will need to go back and make sure that you know those as well. Again, if you have any questions, I hope that you will be sure to contact me right away. That's what I'm here for, is to help you. And so I'm looking forward to a great year of physics.